space is not just the most important thing in the universe, but it literally is the universe. And with that comes a lot of mythology and scientific study. Example, space is cold. Not only does space not have a cold temperature, but it doesn't have any temperature. This sounds stupid since, well, everything has a temperature, but that's also kind of the point. Everything has a temperature. And vacuum, what's usually referred to as space, is the near total absence of things. And since a thing zooming around is hot and a thing standing still is cold, no thing means no temperature. Sort of how you can't have a shiny metal coin without any metal. Now the part that makes the least sense of this is that it doesn't mean that if you were thrown into space, you'd simply stay the same temperature. Your body would slowly lose heat through radiation. Not Chernobyl radiation, but heat escaping as infrared light. So is space cold? Kind of, but not really. It's not cold, it's nothing, and nothing is way deadlier than cold. Also, remember how I mentioned that temperature is just vibration? Well, so is sound. In the most basic levels of reality, all that sound is literally just particles hitting each other until they reach your ear, which is what you end up hearing. Using your genius intellect, you've probably already figured out that without these particles, there is no sound. Thing is, the average person considers this to be space just as much as they considered these gas clouds to be. And within these gas clouds, you can hear these nightmarish sounds. That is the sound of stars being formed, pure nuclear fusion. So, is it cheating to point at some specific part of space and say there's sound there? No, because if you pointed at an oasis in the desert and said there's water in that desert, you wouldn't be wrong. Just telling that to the guy who's on the complete other side of the desert would make him a bit annoyed. And on the topic of water, a lot of people think Neptune is blue because of water, but Neptune neither has water and nor is it blue. That deep mystical blue we've all seen is all pure Photoshop. Ever since the first flyby mission in 1989, NASA has been popularizing a fake version of Neptune with a saturated filter on it. It's the same as if we thought polar bears were blue because anyone who ever took a picture of them always put a blue filter on it. The reason NASA applied the filter in the first place was to make the features easier to see. But if you were to actually get on a rocket, fly for a few years, and get to Neptune, it'd basically look exactly the same as Uranus. Nearly identical side by side. Strange thing is though that in theory, Neptune and Uranus should actually look like this. It's just that they're so far away from the sun that even though their atmospheres are filled with methane, which reflects blue light, it still looks completely pale. Nowadays, most people are so used to the fake version of Neptune that when they see the real version, they think that's the one with the filter on it. Now, about the sun. If you were to ask somebody what color it shined towards us, they'd probably say yellow, since when you stare at the sun, it does appear to be yellow. And this time, it's not because of a filter NASA put onto it, but it's because of the one Earth's atmosphere did. You see, basically everywhere in space, even most of our solar system's planets, the sun appears white. It's only once it passes through the atmosphere, and colors such as blue are spread across the sky, does the sun start appearing yellow. And the denser with particles our atmosphere gets, the more of a warm color it becomes. This is very easy to see when there's a bunch of smoke or smog in the air and the sun becomes orange. That's the same reason why people used to think the moon was made out of cheese, because all of the wood they burned to heat their homes caused a huge filter to appear, resulting in it appearing yellow even though it's just white and gray. Speaking of which, the concept of the dark side of the moon is completely fake. Though the moon does have a backside, which it's too shy to show, which is ugly as fuck by the way, glad we got the pretty side. It's not usually dark. In fact, it literally gets the same exact amount of time in the sunlight as the part we see, down to the minute. The dark side of the moon is most known for looking quite a lot like Mercury. Speaking of which, Mercury, though it's the closest to the sun, is not actually the hottest planet in our solar system. It's actually Venus. You see, just like Earth, Venus has an atmosphere. Only difference is that it's 93 times heavier, meaning if you were to somehow end up standing on Venus, you'd instantly be turned into a puddle, and then that puddle would be boiled. Only in a submarine would you stand a chance, since the weight of the atmosphere is equivalent to standing 900 meters underwater. Anyway, point is, the atmosphere is amazing at taking all of the heat that the sun brings in and keeping it, becoming the solar system's largest and hottest greenhouse, reaching and maintaining temperatures of 900 degrees Fahrenheit, day and night. By the way, a day on Venus lasts 243 Earth days, so good luck. Anyway, I got a bit sidetracked of how hot Venus was. Point is that Venus has an insane atmosphere. Mercury, on the other hand, has literally none, meaning during the day the temperature is 800 degrees Fahrenheit, with a lot of it simply reflecting back into space because of the lack of an atmosphere, and at night it's 900 degrees Fahrenheit. Also, did I mention that days on Mercury last even longer than on Venus? Instead of 243 Earth days, they last infinite. That's because Mercury is so close to the sun that it's physically locked indefinitely facing it. It's the same thing that the moon has with Earth, which is why we only ever see one side of it. Now, I couldn't think of a transition here, so here's the next myth. Astronauts float in space because there's no gravity. There actually is gravity in space, and in fact that's the reason they're floating around Earth. It's a bit of a brain melt, but to explain how it works, imagine you have a ball and throw it super hard. And I mean super hard, to the point that it's going 28,000 kilometers an hour. Now on Earth, the air would simply burn it up, but go 400 kilometers above Earth and the ball would continue falling just like near the surface, but it would be going just the right speed that as it's falling, the Earth below it curves away the same exact amount. Congrats, you now have what scientists call controlled orbiting freefall. Now throw it too lightly and it falls back down into Earth, and throw it too hard and it flies off into space. But at this perfect speed, you get what people like to call zero gravity. But the right way to say it, and also intensely nerdy geeky way of saying it, is apparent microgravity environment due to continuous freefall towards Earth. So if you ever want to appear really cool at a party, just say that. Another way to ruin the fun is informing everyone at the function that black holes don't actually just suck things into them like in the movies, where they suck in suns, planets, hopes, and dreams. Rather, they behave literally exactly the same as any other space object. Meaning, if you were to replace the sun with a black hole of equivalent mass, the only difference will be that it'll be darker and colder. But other than that, things will remain the same. It's also because of this that we can even see them. For example, the only picture we have of a black hole is only visible because of all of the light surrounding it. That light being a star which got so close that it was shredded into a ring of plasma. If stars simply went into black holes, we'd never get to see this picture, since black on black isn't the best contrast. This also means that if you were to fall into a black hole, you wouldn't get to experience your Thomas Shelby badass moment. You'd simply be shredded into a million pieces and thrown into the singularity. Also, what we see and call a black hole isn't actually the black hole. It's simply its event horizon, where the pull of gravity is stronger than the speed of light. Basically, it's just a sphere surrounding the super dense middle point where anything that goes in can never be seen again. Calling this outer shell the black hole is sort of like calling the moon part of Earth just because it's within its gravitational pull. But again, would not recommend saying this at any parties. Now going back to the solar system, something that would always keep me up at night as a 10-year-old was thinking about future travel to places like Jupiter, especially after I heard about this massive thing called the Asteroid Belt, which was supposedly between Mars and Jupiter. Truth is though, is not some chaotic death trap where you need Jedi level reflexes to dodge spinning space rocks. That's pure Hollywood. In reality, if you were to magically teleport into the middle of the asteroid belt between Mars and Jupiter, you'd be greeted by absolutely nothing. You wouldn't even know you were in it. The average distance between two asteroids is not a few meters like in games and shows, but rather 600,000 miles. That's more than twice the distance from Earth to the moon. You could fly through it 1,000 times and never see anything larger than a speck. And yeah, there are millions of asteroids. They're spread out over such an astronomically large area that calling it a belt is super misleading. It's like calling a few crumbs spread across a football field a cookie belt. The reason movies make it seem like there's a cosmic demolition derby is simple. Floating through emptiness doesn't exactly scream amazing space adventure. So next time anyone says that the asteroid belt is dangerous, remind them that statistically you're more likely to be hit by a bird on a plane than by an asteroid in the belt. And then after saying that, you can perform your Thomas Shelby badass walk. Another myth that was caused by Hollywood is that if you take off your helmet in space, you'll explode like a water balloon in a microwave. Blood everywhere, limbs flying, overall not a good day. In reality though, just like with the asteroid belt, it's not even close. You don't explode, you don't freeze instantly either. What actually happens is actually somehow both way more boring and way more terrifying. First off, as mentioned earlier, space is a near perfect vacuum, which means there's no pressure holding your body fluids in. So yes, the water on your skin and soft tissues would start to boil, but not from the heat, but rather from the lack of pressure. It's called ebulusum, which simply put makes you a weird humanoid pufferfish. You just kind of awkwardly stay like that. That's because skin is actually surprisingly tough, basically like rubber. The worst part of this is that you can't do anything to escape, since you lose consciousness in about 15 seconds, since most of the oxygen in your lungs rushes out through your mouth. It's the equivalent of putting on the most powerful vacuum on Earth right onto your mouth. It's funny for the first second, but not so much after two. Some of you may have already thought of a possible solution, just close your mouth and pinch your nose, but that's actually the single worst thing you can do in this situation. You'd rupture your lungs. And technically, yes, that does mean some internal organs may explode, but it's not some cinematic explosion. You'd just suffocate, swell up, and after a minute or two, you'd become a frozen piece of meat, floating in space until you crash into some planet or burn up in a star. I guess it'd give you enough time to binge all my videos though, so that's nice.